So we are dealing with the eighth problem in this series. The eighth problem is stating a thin half ring of radius 20 centimeter is uniformly charged with a total charge of 0.7 nanocoulomb. Find the magnitude of the electric field strength at the curvature center of this half ring. So if we approach this problem, we will calculate it for any angle theta, then we will use it for the ring. So over here we have problem 3.8, and to understand this we are considering a situation like this. So we are drawing a curve like this, and now we are selecting a point over here, say at an angle theta. We are selecting a patch over here which is at d theta. So we are selecting this charge being equal to dq, and we are considering lambda as charge per unit length. So the length that we have selected is dl, which is equal to r d theta, and therefore it will have a charge lambda r d theta. So electric field due to this will be in this direction, that is equal to dE, and we can have two components for the field, that is dE cos theta and dE sin theta respectively. So we will have a cos component over here and a sin component over here. Now since there is a symmetry around this system and the charge is uniformly spread, all the dE sin theta component and dE cos theta component that we have, so only cos theta component will contribute. All the sin theta component, because of the charges on this left hand side, will be balanced by the charges on the right hand side, and hence we are not integrating dE sin theta, as the result will be equal to 0. So therefore we can say that electric field strength can be written as integral of dE cos theta. So over here we write it as integral dE can be written as kq by r square cos theta, and therefore we write the magnitude of electric field strength is equal to k by r square. Integration dq can be written as lambda r d theta cos theta, and the limit is from minus pi by 2 to plus pi by 2. So this is the limit that we have. So magnitude of electric field strength can be written as k upon r lambda integration of cos theta d theta minus pi by 2 to plus pi by 2. So since we are doing it for a half ring, so we are using it as minus pi by 2 to plus pi by 2, and therefore the value over here is turning out to be k lambda upon r integration of cos theta sin pi by 2 minus of minus plus, so we are writing 2 sin pi by 2. So the magnitude of electric field strength can be written as 2k lambda by r. So if we substitute the values, so we can say 2 upon 4 pi epsilon naught into 1 by r, and this can be written as charge upon length being equal to pi r. So charge per unit length, that is q upon pi r, and on solving we get q upon 2 pi epsilon naught r square, 2 pi square epsilon naught r square. So this is the value that we have, and if we substitute the values, so we have q given to us as 0.7 nanocoulomb into 10 to the power minus 9 upon 2 pi square epsilon naught, and the distance r is 20 centimeter, so 20 by 100 is square. The answer will be in volt per meter, which on solving we obtain as 0.1 kilovolt per meter. So these are the two necessary answers for this problem. One is the answer where we put the values as q upon 2 pi square epsilon naught r square, and the other on substituting the value which we obtain 0.1 kilovolt per meter.